Hey everyone. When we talk about data, we always hear about these incredible game changing insights. It almost feels like magic. But here's the thing, before any of that magic can happen, there's this super important behind the scenes step called data preprocessing. Today, we're going to pull back the curtain on that process. Think of it like this: we're turning a chaotic mess of raw data into clean, hard evidence. Let's get into it.
And that's a totally fair question, right? You've got all this data, so why not just dive in and start analyzing? Well, because real world data is messy. It's like a crime scene before the forensics team gets there. It's just a jumble of clues. Some are missing, some don't make any sense, and some are just plain wrong. If you try to use it as is, you're pretty much guaranteed to come to the wrong conclusion. So let's put on our data detective hats for a minute. On the left, that's what we start with, the raw data, our chaotic crime scene. We've got missing pieces of information, we've got inconsistent formats, we've got stuff that's just flat out old. Our job, our mission, is to turn all of that chaos into what you see on the right, data that is complete, standardized, and totally reliable. That is the only way we're ever going to solve the case. Okay, so let's officially start our investigation. And the very first rule for any data detective is to accept one simple fact. Real-world data is almost always dirty. So before we can even think about finding those brilliant insights, we first have to really understand the kind of mess we're dealing with. Now here's a really important concept to get your head around. Data quality isn't a one-size-fits-all thing. The same exact dataset could be pure gold for one person and complete garbage for another. For example, a marketing team might have a customer list that's about 80% accurate. For sending out a big email blast, that's probably good enough. But for a sales manager trying to create specific sales territories, that 20% error rate makes the data totally useless. So before you start cleaning, you have to know what problem you're trying to solve. All right, so we get it. The data is a mess. So what's our first move as detectives? We survey the scene. This is all about getting the lay of the land, you know? We need to understand the basic characteristics of our data. What does it look like? How's it all put together? And most importantly, where are the problems probably hiding? And this right here, this is our main case file. It's called a data matrix. It's basically just a simple grid. See, each row represents an object, in this example, a customer, and each column, that's an attribute, a characteristic about that customer, like their age or their income. It looks simple, but this structure is the foundation for pretty much all data analysis. Now, to make any sense of our case file, we're going to need the right tools. Think of these statistical measures as our detective's toolkit. They let us go beyond just the surface-level facts and really see the spread and the shape of our data. This helps us spot what's normal and, more importantly, what isn't. The simplest tool in the bag is the range. It's exactly what it sounds like, just the difference between the biggest value and the smallest value. It gives us a quick, first-glance idea of the boundaries of our data. Are the ages in our file between 20 and 70, or are they between 5 and 105? It's a basic check, but it's a really important first step. Okay, now for the more sophisticated tools, variance and standard deviation. What these really tell us is how consistent our data is. A low standard deviation means all the data points are huddled up really close to the average. They're all pretty similar. But a high standard deviation, that means the data's all over the place, which could be a sign of a major problem, or it could be a really important clue. So, we've surveyed the scene, we've got a feel for the data. Now comes the hands-on part. This is data cleaning. This is where we literally roll up our sleeves and start fixing the issues to make our evidence solid and usable. One of the first problems you're always going to find is missing data, just empty spots in our file. As a detective, we have a few ways to play this. We could just ignore that record entirely, but then we might be throwing away other good information. We could try to fill it in by hand, but with huge data sets, that's just not going to happen. So, often, we'll either use a global placeholder like unknown, or we'll calculate the average value for that attribute and just plug that in. Every single choice has its pros and cons that we have to think about. And the mess isn't just about what's missing. It's also about what's there. We have to hunt down all these little inconsistencies, like dates being formatted in a bunch of different ways. And we also have to look for something called field overloading. That's when a single field, maybe a comments box, is being used for everything. Customer complaints, product codes, employee notes, you name it. It's our job to find all that junk and standardize it. So, once our data is nice and clean, we're not always done. The next phase is what we call data transformation. This is all about changing the format or the structure of the data to make it a better fit for the powerful data mining algorithms we want to use later on. A really key transformation technique is called normalization. Okay, Imagine you have two attributes you're looking at: a customer's age, which goes from, say, 0 to 100, and their income, which could go up into the hundreds of thousands. If you don't do anything, that massive income number is just going to completely dominate any analysis. So what we do is we scale everything down to a common range, like 0 to 1. It puts all our clues on a level playing field. Another really powerful trick is called discretization. So instead of looking at someone's exact age, like 37, we can just group them into a broader category, like adult. This helps simplify the data and can actually make it way easier for algorithms to spot those big, high-level patterns, like figuring out which age groups are responding best to a marketing campaign. So, let's take a step back. We've surveyed the scene, we've cleaned up all the messy evidence, and we've transformed our clues into a usable format. As we wrap up this part of our investigation, let's get to the final verdict. Why does all of this incredibly detailed, behind-the-scenes work matter so much? You know, it all comes down to one simple, powerful, and absolutely unavoidable rule: garbage in, garbage out. If you feed your analysis messy, incomplete, unreliable data, you will get messy, unreliable results, period. The quality of your final insight, that big aha moment, is completely dependent on the quality of the evidence you start with. So, we've done it. We've taken that chaotic crime scene and we've turned it into a clean, organized, and reliable set of evidence. Our pre-processing investigation is done. And that leaves us with the most exciting question of all. Now that the data is finally ready, what hidden stories is it about to tell us?